The super popular AI agent OpenClaw just got hacked again. The Hacker News put out an article on the 28th of February reporting on a vulnerability discovered by Oasis Security. This vulnerability allows an attacker-controlled website to use JavaScript to interact directly with a local host-bound OpenClaw instance. That could potentially lead to complete hijacking of the OpenClaw AI agent, exfiltration of sensitive data, and as we'll see, I've made a proof of concept which demonstrates the impact of potentially proxying that WebSocket through the victim's browser and to an attacker, which would then allow you to interact with the bot in a chat interface, even though it's bound locally to the victim's computer. It's quite a technical vulnerability, so I've drawn up a cool diagram, or at least I think it's cool, to explain what's going on here. So we have the victim PC, and on the victim PC we have the local OpenClaw instance, which is bound to localhost 18789. And that bound port is running a WebSocket server. Obviously, OpenClaw has access to all your private data on the computer. It can run shell functions. It can do whatever you can convince it to do. It's kind of like talking to a child and asking it to do something, and it'll say, oh, no, I don't want to do it. But yeah, there's some people out there that have extremely complex OpenClaw setups that may not be secure, but they have a lot of functionality, moving crypto around, accessing the web, running shell functions, coding, managing deployments of software, anything along those lines. I'm sure there are people out there doing it. So how does this attack work? Well, we have the victim PC and we have a browser. The victim browses to our attacker-controlled website, attacker.com, and on that server we have a Nginx reverse proxy running, and in the background we have a Python Flask application. And this Flask application starts up a WebSocket, and it also delivers the JavaScript. Okay, the WebSocket is for the greater attack that I've developed in this video for demonstration purposes. It's not groundbreaking. I just thought it was cool. So Flask delivers the JavaScript. JavaScript ends up in the browser of the victim, which is then executed. That JavaScript attempts to connect to the OpenClaw local host WebSocket. OpenClaw has authentication on that WebSocket. It can either use token authentication or it can use password authentication. And what this JavaScript payload does is it connects to that WebSocket and then attempts to brute force that password authentication using a word list. And because people think anything that's on your local host is safe, they probably use a weak password. So your chances of brute forcing that password are pretty high. And for some technical reasons, you can get past the rate limiting on that WebSocket because there is no rate limiting on that WebSocket, which allows you to try a whole bunch of passwords really quickly. I think the Oasis security report said that they were getting multiple hundreds of passwords a second being thrown against that authentication mechanism. So once you found that correct password, in our instance in the attack it's going to be OpenClaw pass, but once you found that, then you can authenticate to the local OpenClaw instance. So once you've authenticated, your JavaScript payload could run whatever you want it to run. It could run a message, it could send a message to OpenClaw and be like, hey, can you please print env and give me the output? And then that JavaScript could take that and make a web request to another server, exfiltrating that data. But we'll see how this works in a bit. So that's the simple attack, which is what was demonstrated by Oasis Security. And I made a little proof of concept here. Flow, here we go. So the victim browses to this website, the JavaScript is loaded, the WebSocket's connected, it brute forces the password, finds the password, it authenticates to OpenClaw, and it sends the query here, please read etc password and return the data to me. And OpenClaw happily goes and returns that data. This data is being controlled by attacker-controlled JavaScript. You could do anything with it. So this is a proof of concept of the vulnerability here. You can brute force the password on the local WebSocket server and then interact with it in any way you want with JavaScript. But I took it a step further. I thought this is really cool and it's great, but there's something more that you can do. I wanted to proxy the WebSocket to an attacker on a different web page so that you could then interact with that local OpenClaw instance through the victim's browser in a whole separate chat interface. So this is what the victim's going to see. The OpenClaw security guard. This could be a phishing pretext. Get someone to click a link, trying to figure out how to secure their OpenClaw. Meanwhile, you're hacking them. So they click this, then through this web server, which I'll explain in a second, the attacker sees this on a different page. Victim connected. Hey, Claw, you there? Yes. Can I help? Can you please print env? And it will return the output. So that seems like a really cool thing, to me at least. It's taking the attack that we saw earlier just a step further and making it slightly more impactful. So let's see how that works. Step 1, victim uses their browser to connect to attacker.com. Step 2, attacker.com sends the JavaScript. The JavaScript is executed. Then we connect to the OpenClaw socket with JavaScript. We brute force the password, authenticate to OpenClaw, and then we connect the victim browser to a web socket on the attacker.com domain. Then we have step 5. The attacker opens their browser, connects to attacker.com to a separate page. Then they get a chat interface, and then we can issue a command. We issue a command through the WebSocket. The WebSocket sends that to the browser because the browser on the victim PC is connected to the WebSocket on attacker.com. That command is then sent through the JavaScript, sent through this WebSocket, sent to OpenClaw. OpenClaw happily accesses the private data. OpenClaw then sends the reply through this WebSocket back to the JavaScript, back to the browser. The browser then sends it back to attacker.com through the WebSocket. And eventually that ends up on our attacker PC. And we receive that reply from the command that we sent. Now, that might sound like a lot going on, and I guess it is, but I have a demonstration here that's going to make it a lot clearer. So this is what's happening on the victim's browser. The JS is loading, WebSocket connected, brute force, password found, authenticate, send the query. This time, instead of sending a query via the JavaScript, we're going to ask another page on the website, which is going to be where the attacker is, to send that query, and then we'll get the reply all the way back there. So we have a local OpenClaw instance running on port 18789 as usual. It has a password. The password is OpenClaw pass. And now if I open attacker here, we'll see the chat interface waiting for victim to connect. And now as soon as the victim clicks the link, OpenClaw security guard, they're learning how to secure their OpenClaw instance, and we on the attacker side get victim connected. So what can we do? Hey Claw, please print env and give me the output. And it takes a while, maybe 30 seconds, and boom, we get the output. We get a reply from OpenClaw saying, here's the environment variable with sensitive values redacted. See, this is what I was talking about with the whole child thing. You're talking to this AI and being like, hey, please do this, and it chooses not to. And then you have to go through a whole script trying to convince it to give you these sensitive API keys and tokens and whatnot. But yeah, it did the thing. We have successfully hooked into a victim's browser using JavaScript and then executed a command from a different web page and proxied it through the victim's browser into OpenClaw and received the reply. I just think that's amazing. I was really stoked when I got this working. So just to give you some insight into what's happening on the victim's browser, I've opened up the victim.html here in my code editor to show you what JavaScript is actually running. So when someone browses to attacker.com/victim, they are served this document. And this .html document is then interpreted by their browser. And in this document, there is JavaScript. So when the browser comes across that JavaScript payload in this document, it sends it to the JavaScript engine, which then executes the code connecting to the WebSocket. So here in this victim.html, we have just a standard HTML document with some CSS styling to make it look nice. We have the OpenClaw security tutorial with some dummy data. And then we have the script tag. This is where the JavaScript lives. The JavaScript connects to the WebSocket. It performs the password brute force with this word list. It also sets up some necessary fields of information when communicating to the OpenClaw instance. There are a few things that need to happen just so it understands what we want to do. And then we also have the send to OpenClaw message. So this is the function that'll execute when we want to send a command over to OpenClaw. And then we're sending that reply that we get back to the relay, which is then sent to the attacker on their web page. So there's a lot going on here. It's a lot more complicated than the Oasis security proof of concept because I've added in this proxy. But I think it was worthwhile, and it shows the impact that vulnerabilities like this can have when you have attacker-controlled JavaScript interacting with host-bound services. So then if you are running OpenClaw, what can you do to fix it? Oasis Security disclosed the vulnerability to OpenClaw's development team, and they resolved it in version 2026.2.25. So if you upgrade to 2026.2.25 or later, then you're fine. Thanks for watching. Have a great day.